Okay, I think we can start now. Well, welcome. I hope you are enjoying Jenkins World the second day, and you learned a lot of things yesterday, and you learn a lot more today. And so I'm Carlos Sanchez. I work for CloudBees, and I'm going to talk about Kubernetes. So while there's still people coming in, how many of you have heard of Kubernetes? Please keep your hands up. Keep your hands up if you have used Kubernetes for any reason, whatever reason it is. So there's a few people. Keep your hands up if you are using Kubernetes in production. So. There's one, two people, three. Good. All right. That's still people coming in. Okay. So a little bit about me. I work at CloudBees. At the time, you should know what CloudBees is. I'm an engineer on a team that builds CloudBees Jenkins Enterprise. So what we do is pretty much scaling Jenkins and everything related to containers, Docker. Now that if you were at Sasha's keynote yesterday, he said we'll be supporting Kubernetes on CloudBees Jenkins Enterprise. So that's the project I'm working on. I'm the author of the Jenkins Kubernetes plugin, which is the one I'm going to talk about today. And I have a long history on open source, different plugins, Jenkins plugins. Back in the day, a lot of Apache Software Foundation involvement, Apache Maven, Eclipse Foundation, a number of other things. And I'm also part of the Google Development Experts Program, which is for people that we talk about or use the Google technologies like Kubernetes. Originally Google technologies like Kubernetes, I guess. Sorry? So if you're coming here to see slides, I'm going to disappoint you. This is the last one you'll see. And we are going to switch to do examples and demos the whole 40 minutes we have left. So I hope you enjoy that. Anyone using already the Kubernetes plugin for Jenkins? Just one person, two person, 3, 4, 5? And of course, you like it, you love it, it's great, it's perfect. There's no bugs, obviously. And if you found a bug, it's a user error, just so you know. And it was designed, it's a feature. Okay, so I have a couple of Jenkins instances here running on Kubernetes. Well, there's still a lot of people coming in, so let me just wait for a bit. A couple of Jenkins instances running on Kubernetes, on Google Container Engine, which is an offering of Kubernetes on the cloud. And I can go into detail later. So I want to make this dynamic. So if you have questions, we'll talk about them. And depending on the time we run, I can go into details on how this is running. But I created this new Jenkins instance. I installed some plugins, especially the Kubernetes plugin, so Blue Ocean and other things. So what you get when you install the Kubernetes plugin, you get what's called a cloud provider in Jenkins. You go to Configure System, and at the very bottom, you can add a new cloud, and you can say Kubernetes. This cloud thing is like a bit of legacy stuff that back in the day when the plugins were creating virtual machines, like in Amazon or any other cloud providers. So what you get today, it's this, right? So this allows you to define a cloud endpoint. So I can go and say, call this cloud Kubernetes, the Kubernetes endpoint. Because this is running inside Kubernetes, I can use the internal names and DNS resolution of Kubernetes. So I can say, yeah, my Kubernetes endpoint is, the default is kubernetes.default.svc cluster local. I can do some things that are interesting, especially if you are outside, running Jenkins outside of Kubernetes cluster. So I can pass the certificate keys and credentials. So typically when you get Kubernetes, you get a self-signed certificate on the API. You would paste the CA here, or you can disable HTTPS checks if you want. You can decide what namespace. Kubernetes has the concept of namespacing. So you can have totally separated containers running in different namespaces. And permissions, there's a number of things that apply per namespace, like quotas, permissions, and something like that. So you can choose what namespace you want to start your Jenkins agents on, which I guess I did mention. This plugin is to start Jenkins agents in Kubernetes. And you can create credentials. And the type of credentials you can add, you can create Kubernetes service account and OpenShift. This would be for OpenShift if you're running on an OpenShift cluster. And the service account will basically just get the token to talk to the API from the file system. Every container or every pod that you run on Kubernetes will have this token set up. Or you can go and create a certificate. So besides the CA authority that you would paste in the other field, here you can upload a full HTTPS certificate that will authenticate you against the Kubernetes API. But because I'm running inside Kubernetes, I can just do nothing, not configure anything. This Jenkins instance is authorized to talk to Kubernetes. So it is not. And one of the things I'm going to do is I'm going to make some mistakes on purpose, so you see how to debug and fix them. I'm going to make some others that are not on purpose, but I will tell you that are done on purpose. And you'll have to figure out which ones are in purpose and which ones are not. So yeah, this is obviously I've done it on purpose. What you get here is, well, the service account doesn't have access, and you will see here, well, cannot list pods in the namespace default. Now, this cluster has role-based access control enabled, which is a new feature in the latest, well, in the last versions of Kubernetes. But it was not enabled by default until recently. And still, if you install Kubernetes, a lot of times it will not be enabled. It depends how the installation goes, how it's configured. But if you enable it, it totally changes the way it works. So before, every pod would have a token that would allow you to talk to Kubernetes API. With RBAC, by default, you get a token that doesn't allow you to do anything. So that's one big change. And there's a few things that are broken in different tools, and like there's especially one pipeline thing that it's broken now due to that. So this is telling me I cannot list the pods in the namespace default. OK, let's try, because I'm running this on a namespace called Jenkins World. Let's try that. OK, so I can list the pods in my own namespace, but I cannot list the pods on other namespace, which, like security reasons, would be a good thing to do, right? Yeah.
You said that the goal of this plugin is to help manage the slaves in the Jenkins master?
Slaves, this plugin will run all your slaves dynamically on Kubernetes. It will create Kubernetes. That's a great question, because I keep the jump ahead. In Kubernetes, there's the concept of pods. You can have a pod that is a set of multiple containers. You can run these pods of containers, the Jenkins slaves, Jenkins agents, in pods in Kubernetes. So this plugin, what it's going to do is every time you have a new job in the queue, it's going to spin out a pod with that is going to become its agent, and it's going to kill it at the end of the job. All right. Okay. So I can configure a bunch of different things, like container cap. Let's leave it 10. Basically, I don't want you to run more than 10 containers at the same time, which is useful at the beginning in case you screw it up. You don't want this to start spinning things like crazy. And I have here the option to add pod templates. Pod templates is what is going to define what an agent is, what a Jenkins agent is going to be in Kubernetes. So I'm going to add one. I'm going to call it Jenkins World. And you can set labels like any other. If you don't set the namespace, it's going to use the one we set for the whole cloud. And you can set labels like any other Jenkins agent. So let's use the label Jenkins World. So you can have different labels matched to different templates. And I'm not even going to touch anything else. We'll go later. I don't have to add containers or anything. Just let's save it for now. And I'm going to create a new job. Let's call it hello. Let's do a pipeline job. And let's do a pipeline. So I can do node, hello, Jenkins World. And let's do sh hello, echo, hello. And let's do it a little bit bigger, or take it a bit longer size, so sleep, 60. Well, let's put 20. So now I'm going to build this. And here, well, it's obviously starting. Here, what I'm doing, let's see what I'm doing. Yeah, I'm watching the pods that are running in my namespace. So can you see it from the back? Okay, sort of. Let's make it bigger. So you see I have several things running here. This stateful set is where it's running my Jenkins master. This service is what allows me to connect to my Jenkins master, basically the front end. And this pod is the pod started by the stateful set to run my Jenkins master. I will enter into details later about the Jenkins master running on Kubernetes if we have the time. But the most important part of what I've done here is that I have a new pod called Jenkins World-something, and this has been just started by Jenkins. Now, if I look at the pod, like describe pod Jenkins World, yeah, this is not going to be great, but it will have some labels, like it's a Jenkins slave. It will have some containers. So when you don't define a container inside the pod template, it will by default launch the JNLP container. That it's the thing that connects to Jenkins and basically tells Jenkins, hey, I'm an agent, and I'm here ready to do work. So you can override this container, but by default, it's going to just start that one. It's going to do some interesting things, like mount into the home directory a new volume, an empty volume. But I'll talk about volumes later. And yeah, this is a pod running and seems to be started and all that. And I can also logs. Yeah, let me start a new window, because otherwise. kubectl. Let's get the transparency off. Logs. get all. Okay, now I have 2 pods running, and we'll see why is that happening. So I can do logs -f and the name of the pod. And I can see this is trying to connect to my Jenkins URL, right? This is my Jenkins URL. That's the JNLP port. So for whatever reason, this is connecting. It's not connected. And I have another one when I only launch the job once, right? So this is something is not going well. And because this is trying to connect to this URL is the external load balancer that is created in Kubernetes to my Jenkins master. So this port is not open. So because I'm running inside the same Kubernetes cluster, this is trying to go outside to the internet and try to connect from the internet, and that's not working. So I go back to configure system, and here, what I can say is the Jenkins URL that you have to connect the agents to is not going to be the default Jenkins URL. It's going to be the internal Jenkins URL. So from Kubernetes, you have DNS resolution internally. So this is going to be this question. My service, Jenkins service, is called Jenkins inside the Jenkins world namespace. So it's going to be jenkins.jenkinsworld.service. And apply. And then I can cancel this build. I'll see. Well, these pods are still running. I can kill them. kubectl, delete this pod, this other pod, and this other pod. Yeah, they will time down because the agent will try to reconnect. It may keep trying to reconnect for a while. If you don't do anything, this would get to the instance cap, to 10. And it wouldn't start more because they see, oh, there's 10 running, I'm not going to start more. Because typically it's it tells you that it's a problem with what you have configured. Otherwise, it would keep spanning things and forever. So, yeah. The default is if you don't set anything, it will use the default Docker, Jenkins JNLP slave Docker image. Yeah, it will go to Docker Hub. It will pull the Docker image and run it. Yeah, and passing some environment variables, basically saying, go to this, connect to this Jenkins URL, this port, and so on. And you can see that now it is working. It's printing the logs. It just worked. And if I only have one running now, and I can say kubectl logs. Well, it's connected here at the bottom. Right, so this is working.
So your Docker image is already being pushed to GitHub, and then
this,
you plugin just downloads it?
I'm not using any, I'm not creating any Docker image. I'm not doing anything. There's a Docker image published by the Jenkins project that we maintain that contains Java and the slave jar. And this is just by default using that image. If you don't override or do anything, it will use that image. You can use your own if you want to.
Right,
Yeah.
but that image is where?
In Docker Hub.
In Docker Hub?
Yes.
So your Jenkins is not, how to get it from there?
Kubernetes is pulling the Docker image from Docker Hub.
Kubernetes, not Jenkins. Your Kubernetes plugin?
Yeah. If you run something on Kubernetes, a Docker image, it's going to go and pull that image and then run it. Yeah. Yes. Is there a way to provide a private registry? Yes. You can, there's a Kubernetes thing that you can set up. And, yeah. You have to run your own Kubernetes, your own registry, and use the name of your private registry image. And then if you need a secret, there's something for providing that secret to Kubernetes, and then it will pull the image. No problem. So I'm going to get one thing that it's also tripping people. Oops. Is I can get the pods that are running, right? Right now my agent died, there's no pod running. But if the pod enter in error or in termination, you won't see it until you set -a to kubectl get -a pods. And this will tell you if there's any pods that is not running and it's been terminated or something. So if you have any issues, you should look at the -a option. So let's watch it again, and let's run this multiple times. So I can build multiple times, yeah. And there will be several pods coming up. Kubernetes is going to launch these containers. The container is going to connect to Jenkins, and Jenkins is going to see it as any agent. And that's how it works. Infinite scale by whatever definition of infinite is that you want to use. Yes? Would you suggest having separate masters and slaves in different Kubernetes? No. It depends on your use case, but typically not. With Kubernetes, it's really easy to have isolation in one cluster. Yes? MS build, like building on Windows? No, not today, at least. I mean, just recently, I think it was this week or something, you can run Docker Swarm on Windows. The Windows support is still not there yet. But that's a Kubernetes thing. What you can do is the same way. So here you have infinite scalability on Kubernetes clouds, but you can still connect external agents. So if you need an external agent that is on a Mac or it's on you can still do that. I mean, this doesn't prevent you from doing anything else. And you see there should be 10 pods only running, and there should be, because my instance cap is 10, so there's jobs in the queue. They will just wait for these pods to finish and start new ones. So if I refresh here, well, there's things still running, 453. Yeah. Now, this is useful already. This allows you to use these containers on Kubernetes, on a cluster, and so on. It's great. But there's a really nice feature that was added to the plugin, which is support for pipelines. So if I go back here and I create a new item and say this is going to be a Kubernetes pipeline. What I can do is, instead of using the pod template that I have defined in the configuration and having to go through the UI and create these configurations, I can come here and say, we can look at the pipeline syntax. I can find here something, or maybe not. It's not here. It should be here. Well, doesn't matter. What I can do is I can create a pod template, and I could say, I think it was name. Label, sorry. Label, and I can say my pod. And I can say node. my pod, and then echo message, echo my pod, and let's just sleep. No, sorry.
Does this plugin work on both the scripted as well as the declarative pipeline?
Yeah, there's also support for declarative. Yeah. If it has support for declarative pipeline, and yes, it's just, hold on for a second. So I have defined a new pod in my pipeline. I can have this pipeline checked in Git. So now I can move like infrastructure as code. I can also define my Jenkins agents, what containers I want to use, into my Git or Subversion, right? Now, this was really simple, but let's do something more complicated. I can do containers, and I can add a list of containers that I want to use. So let's go here. I can say container, template, Maven. So name is Maven. Image is going to be Maven. And now, what this is going to do is it's going to start a JNLP container and a Maven container, both running in the same pod. So this allows me to reuse existing images. I don't have to create a new image to be my Jenkins agent. I don't have to do anything like that. So image Maven. And how I'm going to connect to this container and run things on my container? Well, using container, Maven, and I can do sh mvm version or whatever. Oops. Let's run it. And let me show you the pods. There's the container is creating right now. And let's look at the log output. kubectl, logs, -f, Jenkins slave, and Maven, or JNLP. Okay, still waiting to start. Oops. Okay, it's running now. The JNLP container, it has connected. And this is running something. And I can see my container has finished in error state. So let's look at what happened here. My pod. So kubectl, describe, sorry, pod. So what I can look at, you'll get events at the bottom. I mean, it's not great to see that, but you will find here this Maven container has terminated with error and exit code number 1. Now, you can also get some information through Jenkins logs. Well, you can get messages like total container cap of 10 reached. This happened before, so it's not gonna. I'm not gonna start more things. At the very bottom, you will see these messages waiting for the slave to connect, and so on. And there should be containers waiting, containers waiting, containers waiting. Okay, and this is and you will see messages start like terminating pods and stuff. So now the question is, why my container entered into this error? And it's because it exited. So with Docker, Docker, there's no such thing as containers, as people say. Containers are just processes. When I run my container, and I'm just running the default entry point or a command, and the command finishes, my container finished. Right? When the process ends, the container ends. So what's happening here is that my Maven container is not doing anything long running. So the pod starts two containers, the GNLP container, the container connects to Jenkins and it's waiting, that's fine. The Maven container just executes something or nothing and dies. So what I have to do is to set two options here. Let's cancel this one, replay. One is TTI enable, for instance. So let's keep a TTI open. And command. TTI enable and command. And I'm using, this is if you go to the plugin page, you will see this in several examples. This is basically run cat and do nothing else. So you keep the process running and keep the container running. Because I don't want, this would be the PID one in the container. This is going to run forever until the container is killed. And then these container instructions are going to get into the container and execute things. And it's all going to work, hopefully. And let's look at this again. There should be a new. Let's delete this one, because it has error state. The plugin is not going to delete these pods that enter in error, so you have the chance to check what's going on. Oops, kubectl, delete. Pod. Yes, OK. Now, another thing that people ask a lot is why my containers take a long time to start. And it depends on the Jenkins API. There's a couple of system properties. If you go to the container page while this is running, or sorry, to the plugin page. There is the plugin. You will find a couple of examples. And a great explanation of how this works. So you can set a couple of system properties that will make Jenkins be more proactive into launching containers. These settings are there back from the cloud days, where spawning a VM takes 10 minutes, and then you wouldn't want to span VMs continuously, and so on. So this is one of the things that you can configure. So if I look at my pipeline, time now waiting for containers to become ready. So let's look at what happened here. Oh, it has error again. All right, so let's look at what happened here. kubectl, get apods, kubectl, describe pods. Right, and the container didn't get ready. Why? Exit code 1, again, in the Maven container. So let's get the logs. OK, so there was a build failure because I used the wrong ambient command, which is probably -v. So let's replay this. So what happened is I executed the Maven command. Maven returned 1. That gets pushed over to Kubernetes, and Kubernetes will tell me your command that you executed, it ended with an error. Because typically the commands will not end with errors. So here we are again and trying. And let's delete it. Oh, it's already been deleted. It is running. Let's see what happens. Success, right? Maven home and whatever commands. So this is a way to figure out what's going on. I mean, these systems, clusters are complex, all the containers, processes, exit codes, and all that, right? So I'm going to show you now other examples that I have pre-made. So another thing that you can do that is very powerful is multi-container builds. So you don't, the one I show is just running, well, it's actually running 2 containers, the GNLP and the Maven one. But something that is really nice is the ability of having builds that use different technologies without having to create your own Docker image. So if I look at this build, I'll show you the pipeline. What this build is doing is building Maven and Golang, 2 things, totally different technology stacks in the same pipeline. So I'm using 2 containers. One is using the Maven image, the other using is the Golang image, and the same things that I mentioned before, just keeping those containers running. And what you're saying is, in the container Maven, run Maven clean package, and then in the Golang container, do a make build. I mean, it's creating the Golang structure, folder structure. All these examples are in the plugin page, and then basically this is creating 2 different containers. I don't have to create any Docker image that is specific to this build or this job, and that's something that is unique to the Kubernetes plugin, the ability of having multi-containers that you can reuse all the public containers images that are out there, and you don't have to do anything extra. While this is running, let's go back and show you more of the other examples. When you run multiple containers, these containers in a pod can access each other using localhost. This is something characteristic from Kubernetes. So this becomes really useful to try for testing when you have, I want to run a Maven build that connects to a database and does something. So that Maven build can connect to the database in localhost and whatever port the database is running. And the other thing you can do, like in this example, is run Selenium. So I'm not building any specific Docker image. I'll show you. Play. This is a bit more complex. Oops. Okay. For one reason and one reason only. So I'm running a Maven build that executes Selenium tests against Firefox and Chrome. So what I'm doing here is having 1, 2, 3, 4, 5 containers. One is running the Maven tests in Firefox. The other one is running the Maven tests for Chrome. Another one is running the Selenium hub. If you know Selenium, you have a hub, and then you can have multiple Selenium nodes running. And then the 4th is the Selenium Chrome node, and the 5th is the Selenium Firefox node. So the Maven build on Firefox is going to run the tests against the Selenium hub, asking for a Firefox browser. The Chrome one is going to ask for a Chrome browser, so you have 2 tests running against this Selenium hub. And I'm running all of this in parallel. So I'm saying with pipeline, parallel, and in the Firefox, just go to the Maven Firefox container and run the Maven build. On the Chrome container, run the Maven build, passing a different parameter. And that's it. All the complexity here that you see is that because these Docker images are designed to be run as in Docker Compose, so you have to just pass some extra environment variables so they don't collide imports. So here I'm using the display 99 and here the display 98 because by default they use the same one. So you have to kind of work around some of these limitations. But this, okay. So this is running the Maven builds in parallel, Chrome and Firefox. And then the other step that I added at the end is the log step that was recently added to the plugin. Okay, so I can see the logs in Chrome, Maven build in Chrome, the Maven build in Firefox. So this is like any other. Okay. No. Yeah, this is just, okay. Just running Selenium against Chrome and checking that one phrase is in there. And then the Selenium, the container logs is, so I was a recent addition. So you can also get the logs from the containers and print them. So Selenium Chrome, because you're not executing anything in there, you just want to get their standard output for whatever reason, because you just want to check that whatever the database you are running, that's not errors in there or anything you want, you can get those logs. The same logs you can get with kubectl logs, you can get them through here. Yes? I'm not running Docker Compose. It's not a I don't know, what's your question? Where I'm running 5 containers? Yeah, okay. So these images that are published in the Docker Hub by Selenium, their examples are all set up for Docker Compose. So for me to reuse them in a Kubernetes environment, I had to change environment variables. Because in Kubernetes, so these images, when you start the Selenium Chrome and Selenium Firefox images, they will try to bind to localhost port, I think it's 5555. So because in Kubernetes, one pod shares networking namespace. If I try to start 2 containers in the same pod that try to bind to the same port, 2 containers in the same pod that try to bind to the same port, one of them is going to fail. So I'm passing environment variables to just say, you bind to this port, you bind to this other port, and because this is using also the, you could use Selenium recording using the display buffers and stuff. You gotta make sure that they don't collide on ports. That's the only complexity in this in setting up this pod. And let's show you another examples. The declarative one. I think that's going to be it for today. Did we lose the internet? Okay, well, I'll show you here if this is not loading now. You can find the examples here under the Kubernetes plugin. With declarative, the only problem with declarative is that as I mentioned before, the ability of having multiple containers in one agent is unique to this plugin and to Kubernetes. you can only have one container template here. That's the limitation that is there for now. So this is defining an agent on Kubernetes, a Maven agent, and then running the same thing I ran inside the Maven container. So this is exactly equivalent to what I showed you in the very first example. And okay, is this right? Do you have any questions? Queue times, okay.
How do you, because when you triggered multiple of these jobs, it didn't queue in Jenkins, right? It queued on the Kubernetes?
It queues in Jenkins and then in Kubernetes. So Jenkins has the queue, its own queue.
But it wasn't visible that, it's waiting on triggering, right? They all trigger.
There's some waiting, yeah. There is some waiting on the queue in Jenkins. Jenkins then calls the plugin.
Yeah, but I'm just trying to, where can you get the data on how long the queue time is?
How long the queue time is, you would have to look that through Jenkins, whatever it's the same Jenkins queue, yeah. Yeah, this is, Jenkins queue is calling the Kubernetes plugin, and the Kubernetes plugin immediately starts the pods, whatever time it takes for Kubernetes also to start them. Like if you don't have resources, they're going to be queued on the Kubernetes side. So there are two queues. And yes, somebody has had a question here. Yeah?
Yeah, I'm old school trying to catch up to this new world. If something goes wrong somewhere, do I have a hope of tunneling into an interactive shell to look around?
Yes, you can always do with kubectl. So I can get the pods running. Now I only have the master, but I can do exec, get me a terminal, the name of the pod, and whatever I want to run. Let's run bash. So I'm inside the Jenkins master. So if I do ls var Jenkins home, I can see everything. Yeah. Yes.
Last question, please.
Okay.
How do you persist things? Like I'm seeing you're hosting, you're mounting to the host. How do you persist beyond that? Consider host filters.
I'm not mounting things into the host. You can, with Kubernetes, you can attach volumes, and there are examples here. One of the samples, like Maven with cache, what I'm doing is attaching what Kubernetes calls a persistent volume. So this is in different Kubernetes clusters, is different things. This could be an EBS volume or NFS mount or whatever. And basically I'm saying, mount this Maven repo cache into this directory in the pod. So you start with a warm cache. But with caching, there's a lot of problems that come with caching. Well, thank you. And if you want to catch up with me, I'll be outside or in the CloudBees booth. So thanks.